Welcome, everyone. I want to warmly welcome you to the celebration of women in wood science. My name is Dr. Christina Eisenberg, and I'm the Associate Dean for Inclusive Excellence and Mabel Clark McDonald, Director of Tribal Initiatives in Natural Resources. I'm going to start with a land acknowledgement and a little bit of a decolonized version of it. We use in the traditional ecological knowledge lab and in the Indigenous Natural Resource Office. I think given the spirit of this gathering, it's an appropriate one. And it is based on the formally vetted land acknowledgement that Oregon State University uses. And then I took it a step further and I had it peer reviewed by Indigenous people, university administrators, college administrators, all kinds of colleagues. So this is my attempt to take us one step beyond the land acknowledgement. We are committed to taking people and the institutions with whom we work beyond the land acknowledgement to find ways to support and empower Indigenous peoples and their communities. We are mindful of the truth that for thousands of years, the Marys River Wampinafu Band of Kalapuya have been in relationship with the land where Oregon State University in Corvallis, Oregon now sits, and we now live and work. We acknowledge that they were forcibly removed to reservations in Western Oregon, and that their living descendants are part of the Confederated Tribes of Grand Ronde Community of Oregon and the Confederated Tribes of the Siletz Indians. We value the long and deep interactions they have with the land and aspire to find ways to honor and manifest that value in our work and lives. In 2022, the Society of Wood Science and Technology celebrated a set of women society members as women ambassadors creating the future of wood science. 16 amazing women, originally from 13 nations, were honored. 7 of these women reside in the US. We are gathered here today in the College of Forestry at Oregon State University to celebrate these US-based ambassadors as a way to promote diversity in wood science. We are also fostering conversations about a broadened definition of wood science, one that is more inclusive, one that may include Indigenous knowledge and traditional knowledge. Our gathering includes Native American and Indigenous alumni and students to join the celebration and make our voices heard. As a first-generation student who is Latinx and Native American of mixed Western Apache and Maramuri heritage, I have faced many challenges on my path to develop a career as a forest ecologist. My current role within the College of Forestry is to support and increase awareness of diversity, equity, and inclusion in a way that is woven into all we do in the college and becomes intrinsic to our work, our daily lives, our partnership, our dreams. I'm here because of the amazing mentors I've had in the College of Forestry and beyond, and because of allies and colleagues such as Doctors Maria Paula Riggio and Gail Woodside, and many other visionary, strong women who are finding their way as women in wood science and forestry. While this path is not always easy, it is filled with beauty, inspiration, and promise along the way. We are here to celebrate the next generation of women wood scientists. And beyond that, taking the Native American 7th generation approach, future generations, long into the future. This is the work we have at hand today, how we create that future for future generations. This is an opportunity for us to learn more about wood science and its promise of diversity and connect across cultures. We are here to strengthen student awareness of and interest in wood science, expand student networks in wood science, find mentors, internship opportunities, career development programs, and find hope and solidarity. Itama Biwa. It's a beautiful dawn. Thank you. Okay, so we have 1, 2, 3, 4, 5 speakers, and 4 of them are 1, 2, 3, 4, 5, 6. Yeah, I was forgetting myself. So the first speakers will be some of the 2022 awardees, and then we have invited another ambassador, and even if it wasn't listed among the SWST awardees, we think that in this college, with this college and beyond, is really doing a great job to promote wood science and wood construction. So we start with Vicky Arian, who will introduce her work within the Society of Wood Science and Technology. Sorry.
Thank you all for coming. Thank you all for coming. As she said, I am Vicky Harian. I'm with the Society of Wood Science and Technology as their executive director. I'm honored to be standing here in front of you as one of the SWST women ambassadors creating the future of wood science. However, I don't have the same kind of background as the rest of the women scientists, the women ambassadors that you're listening to. I don't have a bachelor's, a master's, or a PhD. Even though I graduated 3rd in my class, the counselors said, you know, the best career option for you would be to be a secretary, because you have good math skills, you have good organizational skills, secretarial skills. So I didn't have any confidence in myself at that time to think I could do something different. So that's what I did. I worked for an insurance company in Madison, Wisconsin. I worked for the U.S. Army at a pharmacy in Fort Jackson, South Carolina, and then at a U.S. nuclear missile base in New England, Germany. Then I came back to the Forest Products Lab in Madison, and I became not a secretary, a clerk dictating machine transcriber. That's what we were called at the time. And then project secretary. The other pictures that you see are different pictures of the Forest Products Lab and sorry, the pictures of my projects I work with. And if you can, it's so easy to see, but if you look at them, all the projects I worked with, all of them, the scientists were men. There were no women, and just the secretaries were women. So a little bit different. But I was lucky because my supervisor had the insight to set up a upward mobility position that I was able to take. And for that position, I got to train, I got to learn how to do statistics. I did have to go to get a 2-year associate in science degree from our local tech college and our university. And that allowed me to progress to the research statistician series, where I worked there for 20 years as a research statistician. I retired. Oops, somebody raised their hand. Do I need to do that? Don't worry about it. Okay. Oh, you're doing it. Okay.
They're saying that there's a problem. Can you check?
Oh.
Yeah.
Okay. So I worked there until I retired in 2011. Also, while I worked there. This is where we come into the society stuff. In 1977, one of my supervisors, he was the executive secretary for. He was the executive secretary for the Society of Wood Science and Technology. He said, would you help me with this? Because I got lots of stuff to do. He said, I think it'd be a good challenge. I think you'll like it. You'll love working with the people. So I did. And I worked with him for a few years. And finally he said, you're doing all the stuff. Why don't you just be the executive secretary? Well, that was a challenge because, as you can imagine, since 1958, the executive secretary had been a research male scientist in the Forest Products Lab. So we did work through it, and I did become the secretary, or the executive secretary, and then the executive director. And I have worked with the society for 46 years. And it was because I was working with them as well as being a statistician at Forest Products Lab. In June, I will be turning the gavel over to Angela Haney. She's going to be the new executive director for the society. So please, any of you who are members, help her out. Working for the society did enable me to grow as a person, but also gave me the gift of self-confidence. During that time, I ran the day-to-day operations of the society, answered emails, phone calls, did the financial reports, did website development and worked on that. Did a numerous amount of committee meetings and board meetings, and then also worked to set up annual convention type meetings. With my background as a statistician at the Forest Products Lab, I had a lot of different variety of knowledge, because when our scientists would work on their projects, all the data would come back to us. I'd look at it, me and the people that work with me, and we'd help them decide what their research showed. So I got to learn a little bit about a lot of different things. So that helped in the society stuff, because I would get emails and phone calls, and I could direct some of that information out to people that I thought knew more about it than I did. The thing that I liked the most, and that has been the most fun, is setting up our conventions. So we've done, in 2008, we started our international conventions in Concepcion, Chile. And we've traveled around the world. We've been to the United Nations in Geneva, to China, Slovakia, Brazil, Canada, Japan, and our last international was in Australia. We were supposed to be in Slovenia, but that one ended up to be a virtual. But we will be in Slovenia next 2024. So, but it's been fun. It was fun to set it up, and I got to meet so many people and work with different cultures around the world. So it was a great opportunity. I believe that the people in the wood field, wood science, wood technology, any of the wood related, they're great. They really are wonderful people. They care about other people. They care about our earth. They try to make a difference in the world. And I've been super lucky to have met so many of these multi-talented people. So I don't know how many students are here, but I would like to commend you on your career choice, or maybe one you're still making. What you choose to do is important, and you can change the world. So I would like to challenge you, though, to join the society. I have to make my pitch here, to become involved with SWST. And the ways that you can do that are to submit papers to our two journals, Bioproducts Business and Wood and Fiber Science. These two journals are known around the world. You could attend our conventions. We have one every year. Even numbered years, we are in international venues. Odd numbered years, we're in North America. The conventions allow you to network with other people, learn about research that maybe you didn't know anything about, or maybe you want to cooperate with somebody and start a new project. And the other thing you can do is volunteer on committees and on our executive board. We are always looking for interested people to help. And this is a way that you can make a difference. So I just remember, it's up to you if you can make a difference. Thank you. Oh, sorry. Yeah. Right.
I mean. So Tamara Franca will be the next speaker.
Hello, everyone. My name is Tammy Franca. I'm from Mississippi State, the Department of Sustainable Bioproducts. And we used to be called forest products, but to be more related to what society is today, we are now called sustainable bioproducts. And sometimes it's hard for us to explain, but why? But think about what is wood? Wood is a bioproduct and is sustainable. So that's why we ended up changing our name. So just a little background, I have 2 bachelor's degrees, one in wood technology and one in business. I'm originally from Brazil, and I also have a master's degree in forest science. And then I came to Mississippi State and did my PhD there. And just something interesting, I'm actually from the Amazon area in Brazil, and this is my hometown called Marabá in the state of Pará. And we actually have 2 big rivers in my hometown. And why wood? So this is actually when I started my career. So I can say I have 30 years in this field. And what's funny is that my father had a sawmill, and some of those logs are mahogany, the real mahogany. And then on my master degree, I had to study African mahogany to replace the real mahogany that my father was cutting back in the time as an alternative. So, and in my master's, I had the opportunity to do an internship at the Forest Products Lab. And I was supposed to stay there just 3 months, but ended up staying 6 months and met a professor from Mississippi State. And that's how I ended up at MSU. And I always had a thing for termites and decay. So I still do that today. And then for my PhD, I did a lot of research on Southern Yellow Pine. Sorry, I know we're competitors, Douglas fir and Southern Pine, right? But that's fine. So we did a lot of research on Southern Pine, visually graded how to improve the lumber, because that's our main goal, how we add value to wood. And nowadays, I'm an assistant professor at Mississippi State. I still do a lot of research with termites on mass timber products, decay, and how to add value to underutilized wood, for example, how to make CLT with low value hardwoods. So this is my current team. So I have 2 master's students, 2 PhDs, and this is Amy. And I like my team. You can see I have like pretty much it's half male, female, and a very diverse team. And this really makes the difference. And actually in our department, we are 50-50 female and male. And to me, this is very beautiful. It makes our department stand up from the rest of the university. And as a new perspective, I like to say that students, they need to look wood in a different way. And our main barrier is to tell the people that wood, usually they see wood as a bad side, but actually we are helping the society because there are so many advantages as wood as a biomaterial, right? So it helps the climate change, wood embraces the environment. Wood is renewable, wood is sustainable, and wood can be worked by simple tools, but at the same time, we have a high-tech industry. We have technologies nowadays. And the main thing is that, to me, when I see wood construction, it kind of mimics the forest. So that's how I see. And what's the future of wood science and technology? Students. So I also serve as the student chapter advisor for the SWST, and you are the future. And that's why we need to have you on board. We need you to continue the future of wood science. So that's what I have for today. Thank you.
Eva. So Eva Avyarova will be our next speaker.
Hello. My name is Eva Javierova. It's a mouthful, I would say. But I will start with this very colorful picture because I would like to kind of say that my career in wood science is very colorful. I'm a wood scientist and also product developer, but I would like to say that I feel like a jack of all trades. I have a very rich teaching portfolio. I teach wood ID. I teach strength design of furniture, furniture manufacturing, but also I teach courses like World Forest and Society, global sustainability issues. I research a variety of subjects over time. I'm in this field probably more than 30 years. Value added to hardwoods, furniture strength design, emerging design challenges, school furniture, material sciences, and so on. I have also a very rich extension appointment. It means that I work with industry, which is very gratifying because actually most of my work is applied science. We are trying to kind of combine that knowledge together, that we are seeing the problem in a field and then trying to find some solution in a lab or vice versa. I also work with youth groups, which is also very nice to think about our next generation. This is my origin. Of course, you all detect some strong accent. I'm coming from Slovakia. I just kind of picked this picture because this is castle, which is probably 3 minutes from my house. I used to play there. I used to love to climb trees and then also visiting the castle in these beautiful settings. I started to recognize wood as a material for beautiful things, for historical furniture or maybe other types of products. And I started to bond with this material very strongly. And so my path led to Zvolen University, which was one of the very important and strong university in Europe, where I completed my PhD degree. And then I kind of started to really understand the wood in a different perspective. I really understood that wood is not only beautiful, but also it is renewable, recyclable, biodegradable. And I understood very early on that this is actually a future material for us. And without understanding how we can really use it, we will lose a lot. So I started to be an ambassador for wood first before I started to be an ambassador for wood scientists. This is, by the way, my dress, which I created. And sometimes I kind of have this passion for fashion, and then I was thinking, why not from wood? So I think we can dim one light so we can actually see better.
That corner.
Just not all the way, maybe later. So you're going to like a little bit better. Thank you very much. I traveled extensively throughout the world, and then eventually I end up at Purdue University, a very beautiful place in the middle of the cornfield. I would say it's really a bubble, which happened to be, for those who don't know where it is, it's in Indiana, in Midwest, kind of 1 hour out from Indianapolis. But this university is having more than 40,000 students of all kinds of nations and diversity and so on. And actually, over time, I happened to be a director of Wood Research Laboratory, a lab which had a very nice legacy in wood products more than 100 years. And then I just was fortunate enough to work in this environment and still work there. I helped out to develop several programs. One of that is sustainable biomaterial, which is right now under forestry concentration. I was instrumental in the development of 2 minors, wood products manufacturing technology minor and furniture design minor, which is in cooperation either with a polytechnic school or creative art school. And I actually developed this very unique approach to product development, because when we are trying to create something, we have to kind of look at it also from different perspective. And we know that if we would like to sell something, it needs to be beautiful. First of all, it needs to be beautiful because we need to kind of notice that. And then we need to make it strong and functional, because if you are making something like a chair and it's not really holding the load which is supposed to be on it, something is not beautiful anymore. So we have to kind of add that level of strength. It needs to be also designed a way that somebody can manufacture it, and it can be manufactured feasibly and in kind of ways that it is making sense. And of course, since we understand sustainability early on, we have to also make sure that we understand how it is influencing the nature, how it is going to be used in the future, what is the end of life option for the product and so on, how to loop it all together. So these are the main pillars that we are actually trying to teach our students when we are trying to teach them product development. And that is supported with a lot of coursework which was developed in this area. For example, in area of material science, not only how to identify wood, but also understand the principles of material which can be improved and developed into a new dimensions. Processing, not only a traditional type of processing, but also innovative new types of processing, CNC machinery and so on. Teaching a young generation about sustainability in connection with the material science. And then of course, product development in many different levels. So as I said, I inherited course Wood ID. First of all, I was thinking that it's something completely out of my scale, but I learned how to love it on all levels, even on the level of microscopy and submicroscopy. And I started to look at those cells. It was really a fascinating things. And I started to be more and more interested in natural forms, how to be inspired by the nature, and then teach biomimicry methodology, how to apply it in design principles and so on. But the most important part, and I think Maria Paula asked me to talk about creating beautiful things, creating and working with students. And I have to be proudly saying that we are trying to teach our students to have a hands-on experiences. There is less and less of those schools offering this kind of skills. But I think it's very important that we are going back to the main type of hands-on touch and feel type of experiences. And that's so I think that it's bringing a young generation back to us. They learn how to cut the tree, how to saw the tree into a lumber, how to dry it. Following semesters, they will actually learn how to use the same material for producing some products. They will learn how to prototype fast. They are already skillful in all these computer design programs and so on. They are way ahead of us, but we can actually steer them the ways that they can use them in a more creative way. They learn how to manufacture by CNC manufacturing, how to use lasers, how to 3D print. And this would be an outcome of our work. And so I would have to say that after one semester of kind of understanding this system, this would be a good accomplishment. Some of those products you see there, they are actually the first products ever that created. Some of them are, I would say, successful on competitions or maybe some other shows. And they create beautiful things, tables, coffee tables of all kinds of shapes and forms, inspired by nature, inspired by, what, for example, one in the corner is inspired by Murayil, inspired by traditional arts and designs from different parts of the world. Modular pieces, something that is made from something else, just really a lot of variety out there. Accessories, of course, guitars, many of them didn't even play, but every second boy would like to make a guitar with different flower. Hydraulic harps, or lampshades of all kinds. Just the mirrors and feathers and beautiful things. But, you know, most important part is that we are really building skills. We are recognizing their dreams. And we are just trying to make sure that they are having a very strong feeling of accomplishments when they create their own products. And what is also kind of nice that we can connect them through club. Many of our students are involved in forest products clubs and they earn a lot of money. They could sell those cutting boards for $20 here and there. And then those proceeds are actually helping them to be more global. They travel to study, it takes them to study programs. They travel to Costa Rica several times. I took them to Europe 2 years before COVID, 2 years ago, which I hope to, well, now they're saving money again, so they would like to go back. And what is really important part is to have fun, to involve them in our lives. I think many of them are my children, they call me mother and all that kind of things. They come to my house regularly and then I take them to my trips and my tours. And I really kind of like to watch them, how they grow and how they develop their lives. Here are my models, my graduate students, kind of like presenting my dresses. But what I would like to say here, most important part is we are helping them to find jobs and very good paid jobs. Examples of the some of those career opportunities and they kind of landing product managers, CNC designers, wood scientists, and so on. And with that, I would like to say that we need to be also thankful and grateful. And I would like to be, first of all, thankful to Eric and Maria Paula and US OSU to organizing this event and inviting us, which is really wonderful. And I would like to also thank you to all of those who helped me to grow in my career and fill up my colorful life. Like, for example, this man on a picture was my major professor at the University of California. So thank you. And yeah, did I make it?
Yeah. Very good now.
Good afternoon, everyone. I'm really pleased to be here and will try in a short 10 minutes on how to lead you through my story. I did entitled my presentation as traditional working skills and advanced technologies for the new European Bauhaus Academy, which is something that is today talked a lot in Europe. And I'm coming from Slovenia, a small tiny country in Europe. And I flew here just for this event, and thank you so much for enabling me. And I think that afterwards we'll talk a bit about why this wood ambassador thing was even developed. So, but I will start with me, 1980, and I have two sisters, and my father had a carpentry workshop, and he never considered that we girls were not supposed to work in the workshop. We had to be, and so no Barbies. We were having wooden blocks, and that's how I kind of like got in love with wood. And I decided to go and study wood science at the University of Ljubljana, and been always active already as a student. And I was even a president for a while in the student association. And through that, I somehow experienced international environment already. And then decided to go for a PhD, and OSU was a place where I came, and there was this small device over there in the back. I don't know if it still exists here somewhere in the labs, but Fred Kemke
build it. And so I was here as a PhD student, and afterwards, I actually was working in my field of densification or wood modification, so I didn't like focus on the research topics as much that I was working with, but still I came then back to Slovenia, defended my PhD and started at the University of Primorska, where I'm still today employed partially, and which is by the Adriatic Sea. And I was the first wood scientist employed at the University of Primorska at that time. And then I came back to SU, to Fred, and I don't know, Fred, if you remember, this was my goodbye party when I was kind of going back then after the postdoc here. And I was able to work on a bigger machine that also Fred built. And so I was continuing my research in wood modification, and especially wood densification at that time. And then I went home, and I once came back here and I said, I want to have a PhD student, and I was asking around if there is anyone, and they were saying, well, Nard is the one that decided to go for a PhD, and I somehow convinced him that he moved to Slovenia in 2013 and started working on the topic of wood and human stress in the built environment. And we came up with this idea of a new concept of sustainable buildings, which is restorative environmental and ergonomic design. And back then in 2013, when he came, we got the idea that we should have a new research institute that is focusing on the wood use in buildings. And we were crazy enough that we actually succeeded. And in 2017, we established InnoRenew Research Institute, which is focusing on the use of wood in the built environment, healthy built environment. And it's now 6 years old, and we employ just a little bit less than 70 employees with researchers from all over the world. And we are working on over 50 projects, and the majority of them are related to this wood use in the buildings. And one thing that we emphasized at the time as an idea is that we need to be bringing interdisciplinary science to the wood science itself. And we succeed in attracting the financing for establishing the institute, as well as to get people that wants to work with us. And we have the biggest wooden building in the country as our research institute, and it's kind of like our research. And it's designed by this restorative environmental and ergonomic design that we started developing together. And then, you know, that was 2017, but 2020, there was like an article in Nature published that we have an issue because we are actually creating more mass on this planet than there is actually the biomass available. Plus, there was a study done that demonstrated that 40% of all global emissions are actually caused by the built environment, and that we have over 50% of waste that is created related to the built environment. And this kind of like was a starting point that in Europe, there was a huge kind of push towards how to now replace all these different building materials with wood-based and other natural-based or bio-based materials. There is a pyramid of colleagues from Denmark that they are demonstrating where these different building materials are in terms of the environmental impact. And we have this urge to somehow turn the building stock into carbon stock. And the European Commission in 2021 decided to rebuild somehow Europe and beyond. Maybe some of you are knowing the Bauhaus that was after the war in Germany. there was about rebuilding, and now we are also rebuilding, but the concept is named New European Bauhaus. And it's about doing things in a sustainable way, together and beautiful, so in a aesthetic way. So this was then kind of like a lot of discussions how we can do it, and just this year the decision was taken by the European Commission that at the University of Primorska we established so-called New European Bauhaus Academy, and it's going to be in 2 weeks that the university boards accepted, and the ambition is that we upskill the construction ecosystem with skills for decarbonizing the building stock, and especially by using biomaterials in buildings. There is a huge ambition of upskilling 3 million construction workers around Europe and beyond. And I'm really pleased that this is going to be initiated at the University of Primorska. An official address of the academy will be at Inorinju, our biggest wooden building in Slovenia. And now how to do this, you know? So how to do the upskilling and training of the society in general. So here I have like an example from Istria. So this is where our university and the institute are located. How they were actually instructing how to prune the trees depending on which parts of the Venetian Navy the tree was supposed to go into. And of course, we don't have the patience anymore, and also not the time. We need to be much faster. So today we need to find a way how to build new buildings with wood as a material and other biomaterials, but at the same time, especially in Europe, we have a huge amount of an old building stock that we need to decarbonize as well. And therefore, we need to be very careful, because we as wood scientists, we know exactly what wood means, and that we need to understand it on different levels. And therefore, I hope that all of us together and beyond, we will be able to be educating these different actors in the construction ecosystem. And so this slide was created together with Bob Smith from Virginia, when we were doing like this mapping in US and in Europe of the educational programs that we have. And so the fact is that also we, as the ones that we are skilling up on, also educating the future generations, the wood science needs to be going beyond the chemistry and the material science and all these traditional courses that we would be teaching. We need to be integrating the sustainability, digitalization, interdisciplinarity, social sciences, and of course also creativities, which Eva was really nicely showing. So at the University of Primorska, as said, I was in 2019 the first wood scientist employed, but today we have 2 study programs very closely related to our ambitions in terms of the built environment. So we have a sustainable buildings master program and PhD program in renewable materials for healthy built environments. And one program that we always list is also data science, because that's where we have actually the data scientists, but majority of their work is actually on data that are created in the built environment. And as said, this month, the NEP Academy, where of course you're all invited to be participating and helping us achieving the ambitious goals that we have. And the future, I'm here at OSU again, so you saw there was quite a lot of things in my career related to OSU. So I don't know, maybe one of my current PhD students will come here and further connect us, but so I think that they will be the ones, and I hope that I will be able to support them as I was supported by Fred and by my advisor in Slovenia. And also then further on when we were developing InnoRenew by Casal from Germany, from Fraunhofer Institute. And with that, I would like to thank you. And I don't know, can I conclude with why the so with the whole ambassador thing, how the idea came that we should do it, was that Vicky was emphasizing her 46 years, of work as the university, and we were thinking like what we can do that we can also thank her properly. And we said, let's together communicate about us around the world. And we started the exhibition last year in Australia. And then this exhibition, the posters were supposed to travel around the world. This didn't really work because the post office didn't work, but still we did have the exhibition also in Slovenia. And now we are here, and I think there were a few other places, and we are going to have it in North Carolina in the SWST meeting when Vicky will be saying goodbye to us. And we want that this last year, of travel again around the world would be a thank you to Vicky for all these years, and also, of course, to support us as women scientists, especially as the young ones that we kind of got introduced into the wood community, not only in US, but actually the globe. So.
Okay, so I'm plus one of the women in wood science ambassadors, and then we will have another speaker, but I'm very honored to be here today as one of the ambassadors in wood science. I'm in the wood science and engineering department here at OSU, but I'm not a wood scientist. So my background is architecture. I have a master in architecture from the University of Florence and a PhD in structural engineering from the University of Trento in Italy. So what brought me to wood science? As an architecture student in Florence, I was surrounded by historical buildings. I was fascinated by the history, what this building communicated and taught us. And during those years, Italy was hit by a series of earthquakes that made victims and destroyed buildings, including some of these important monuments. Like this is an image of the St. Francis Church in Assisi, and part of the vault was destroyed in a few seconds with also the frescoes from Cimabue. So it was like a monument that lasted since the 13th century and was destroyed in a second for the earthquake. How it is possible at all that monuments that stood for centuries and resisted so many other earthquakes in the past could have been destroyed? These are images of other reconnaissance surveys that followed other earthquakes in the same regions. As you can notice, one of the strengthening interventions that were made in some of these historical buildings were either replacing or adding reinforced concrete or steel structures to the pre-existing timber roofs. This is, of course, as you can imagine, a terrible mistake because they were adding weight to a structure, they were making it stiffer, so they were basically magnifying the effect of the earthquake. How could it? I mean, how did they do this big mistake? Well, I think that among the various reasons, one is the lack of confidence in wood as a structural material, and the lack of confidence comes from the lack of knowledge. So at that time, there were very few engineers who knew about timber engineering, not to mention wood science. There was a very, I would say, probably there wasn't at all a collaboration among wood scientists and engineers and architects. They were familiar with reinforced concrete and steel design, and this is what they were going for. Like, okay, let's just add this, and it will work. Well, it didn't. The role of wood in historical buildings has been overlooked for a long time, and part of this is due to the fact that these amazing structures sometimes are hidden. They are concealed by other finishing layers. Can you guess that this is a timber structure, that this vaulted ceiling is made of wood? It is. So there are a lot of these timber walls in different parts of the world, in Europe, in Central America, and is a system that has been developed from the 15th century, and especially spread during the Baroque age, because it was an economic way to remodel existing spaces to create these decorated ceilings with frescoes and stuccos, and just using small pieces of lumber nailed together to create these curved ceilings. So way before glue lamp was invented, they found a way to make arches with wood using small pieces. Adding a very limited weight to the pre-existing walls, so very smart from a structural perspective. I started working on this as a master's student, and then early in my professional career, I was interested in restoring some of this structure that suffered some distress. But then I was disappointed to see that some of the previous intervention again showed this lack of confidence in wood and this lack of knowledge. Some of the typical interventions of these structures were just creating a layer like a shell with carbon fiber reinforced polymers. So imagine very stiff. Wood needs to breathe, right? There is a moisture movement between wood and the environment. This is a very this material is not really compatible. And is so there are problems also in terms of reversibility. This type of intervention cannot be removed. So what is done is done, and unfortunately, the authenticity of this traditional structure is lost once this intervention is done. So again, lack of knowledge. I wanted to know more, and so I had the fortune to join what at that time was one of the few schools in Italy and Europe where I could learn timber engineering in north of Italy, in Trento. And I wanted to know how to better assess existing timber structure so that I could have enough information to design interventions that were respectful of the traditional fabric. So I used and combined different non-destructive testing techniques to characterize the material on site. And I started to really appreciate the multidisciplinarity of this field. the multi-scale approach that you need to use when you deal with wood. So you have to understand the material scale, and then you have to, continuously zoom in and out to understand the material and the structure and it's the environment. So it's super fascinating and it's complicated. But this is the way you can respectful approach this material and then design interventions that can be more compatible, maybe reversible. And so we started to test also these techniques. During this journey, I really developed a deep admiration for the lessons from the past, from the traditional knowledge. And there are lessons from different cultures. So this is an example. Wood pagoda in Japan, they withstood so many earthquakes throughout the centuries, while modern buildings were destroyed. Why? Because they developed what now designers think that this is a very innovative approach, that is the low damage design approach. So basically, instead of resisting rigidly against the earthquake, they kind of ride the seismic wave, and in this case, all the stories in the pagoda are able to move, to sway independently, one from each other. They are not rigidly connected, and this central element is a sort of giant mass damper that allows these floors to be stable while they oscillate and also absorb part of the earthquake energy. Pretty much what we try to implement now in our modern buildings. So this is an example of this low damage design that we haven't. The designers have implemented in our building here, OSU, with post-tension rock and shear walls. That basically follow the same principle. We have these walls that instead of resisting rigidly to the lateral forces of an earthquake, will rock back and forth, and then thanks to the presence of these post-tensioned rods, will come back to their original upright position. So there is so much to learn from the past. There is so much to learn from this material if we can be humble enough to really try to understand how this material behaves. And then I'm not for competitions among materials. I think that all can be well used in buildings. It's more about how we design, how we use them. So this is an example of resistance versus resilience, and this approach to minimize damage that allows to not only safely evacuate a building, so to have safe buildings, but also resilient, so that they can be used after a major event. To make sure that this happens, though, we have to understand how this system behaves over time. And so part of the research in my group is to evaluate the long-term performance of these systems. We try to understand all these different phenomena that affect the behavior of the long-term behavior of this system, that including the effects of moisture cycles, of movement induced by moisture, and the combined effects of moisture and sustained loads, and how we do it both on the full scale of the building. So this building is our living lab. We are collecting data continuously through sensors. We are monitoring parameters of interest, and then we are also scaling down and then doing observation in the lab in a more controlled environment to predict, to develop the models to predict this phenomenon. This is important as there is, of course, now as an increase in interest to build taller with buildings. There is a lot of enthusiasm in reaching new heights, and the code allows us now to do so. This means that now there is an increased confidence, right? But we have to make sure that there is also an increased knowledge. Now we are, I mean, the new generation are luckier than the previous one. We have a lot of programs that teach wood science. We are lucky to be in a place where wood science is taught in a very multidisciplinary perspective, collaborating with other schools, with the School of Design, with the College of Engineering, and we see that this happens in many other programs. So I'm positive that new generations will know much more than the previous one, but definitely we want that this increase of enthusiasm and confidence it comes along with an increase in knowledge. So I don't know if you are familiar with the Dunning-Kruger effect, when you are basically it's a sort of cognitive bias when people that are less skilled think they are more self-confident, and people that are more expert, they have less confidence on their skills and abilities. So our work as educators is to make sure that that we increase knowledge and confidence in wood as a structural material, based on increased know-how and skills. Because wood is a complicated material, it is complex. Because it's a natural material, it is unpredictable. Yes, even if we are trying to make it more predictable with engineered wood products. And yes, it may be brittle, it can fail suddenly without so much warning, especially if it is stressed in the world way. But if we do know how to use it, it can sustain larger deformation, and it can absorb shocks. It can work well in earthquake. It absorbs and releases humidity from the environment. So it adapts and regulates its surroundings. It burns, yes, but then it builds a shield and protects its core. So it's resistant, it's flexible, strong, and it's beautiful, much like women. Thank you. So our last speaker is Judith Shiner from University of Oregon. So what do I do with this? Just it's the normal. Okay, great, thank you. Okay, great, thank you. Right, and I'm going to apologize, I'm not an ambassador. You can view me as a visiting diplomat from the world of architecture. So I'm Judith Shine. I'm a professor of architecture over the University of Oregon. I do have a courtesy appointment, thank you, Eric Hansen and the faculty here, in wood science and engineering. And it's largely because of the Tallwood Design Institute. So some of you may know about that. We're a research initiative, which is joint between the Oregon State University's Colleges of Forestry and Engineering and University of Oregon's College of Design. And it's a fairly unique partnership. I guess it's either unique or it's not. So it's a unique partnership. And we do practically everything you can think of that advances engineered timber products. This was the brainchild of Dean Thomas Menes, former Dean of the College of Forestry, unfortunately passed away, but he had this idea, if you were going to get wood products into buildings, that you needed architects. And we were immensely flattered that we were considered useful. So we, in fact, do get wood products into buildings, and we're extremely enthusiastic about it. And recently,
through the joint work we do with wood scientists, engineers, architects, we've managed to jumpstart the mass timber industry in the United States and particularly here in Oregon. And Maria Powell asked me to talk about all this interdisciplinary work, which has recently culminated in a big project, the Oregon Mass Timber Coalition, which was funded by the U.S. Economic Development Administration's Build Back Better Regional Challenge. This was a very competitive process where we, from hundreds of applicants, there were 60 finalists, then 21 funded regional coalitions, and ours was one of the ones that was funded to develop mass timber as an ecosystem. And the funding is for projects ranging from, as we say, forest to factory. So from forest restoration to development of new wood products, all the way through to factory-produced prefabricated mass timber housing. And along the way, create more jobs and economic potential and, we hope affordable, resilient housing, using, again, the skills and the faculty expertise from all these areas. So the coalition is actually a group of public agencies, Tallwood, which is both Oregon State University and University of Oregon, and the Oregon Department of Forestry, and the Oregon Department of Land Conservation and Development, who's looking at changing codes in the state to allow manufactured or factory-built housing to actually be put into various places, and the Port of Portland, who, apart from other things, they're building a huge extension right now to the Portland Airport. Some of you may have flown through it, and it's not quite open yet, but there's a huge new timber roof that's going up with sustainable sourcing of the timber. And there'll be lots of literature about that once it's done. But they also have a site, a Terminal 2 site in Portland that they want to develop as a mass timber campus. And they're very interested in putting and are planning to put a mass timber housing factory there. So that's our coalition, and these are our products. So starting with forestry, the Oregon Department of Forestry is working with the Willamette National Forest to do some environmental review and implementation of forest restoration projects. So part of the forest restoration is removing small trees and leaving larger trees to increase fire resiliency. But that also produces, well, lots of wood fiber, a lot of which isn't considered traditionally useful. So there's a very large project called Smart Forestry that's here at Oregon State University. And there's many, many components to it, and I will just touch on them briefly. There's forest landscape mapping to really figure out what the supply chain is and what's there. Smart technologies involving exoskeletons for workers who are actually doing the logging. And this one, new mass timber design specifications and manufacturing technologies. Well, the way I understand that is that selective harvesting is frankly more expensive to do than just clear cutting. But we are trying to find market solutions to encouraging that. So we're trying to find new uses for these smaller diameter logs and different species that are coming out of the forest to make value-added products from restoration wood that will make them more economically viable. And we're also doing a lot of workforce training at all levels of this operation. And we also got funding to complete kind of a research suite. So there's only 2 research facilities that we don't yet have between the 2 universities. And we got funding to build an acoustic testing lab for floor ceiling assemblies, which is really essential in residential applications. When you build residential work, there's not only standards you have to meet, but probably none of you here have ever been involved in condominium design, but if you are, you have, as an architect, a special rider on your liability insurance, because it's not a question of if you'll be sued, for a fact you will be sued. And in fact, the most frequent cause of lawsuits in multifamily housing are noise. So it's a serious thing. If you're going to put in mass timber in the floor ceiling, you've got to be able to test it. And we're building an acoustic testing facility up at Portland's T2 terminal as part of this campus. And the other big piece is a fire testing chamber, which will go in this campus. This is Erica Fisher, looking like she's examining something in great detail that just burned. who's in the College of Engineering, who specializes in fire issues in wood. And there'll be a fire testing chamber that will be built out by the Emerson Lab. But the other projects are one that I'm actually working on, which is panelized housing. So we know that we can make mass timber compete economically, in some ways do better at larger scales, anything over really 5 stories, where it can compete quite well with concrete and steel, but also do much better in terms of carbon sequestration. And that's, of course, very important if you want to do sustainable architecture. It's been much harder to get it compete economically at a small scale to really compete with stick-built or light wood frame. And you might wonder why we want to compete with stick-built or light wood frame, but we think there are good reasons to do it. So we'd like to get mass timber at that scale. For one thing, the more mass timber market we can create, the more rural jobs we have, the more use we have for restoration timber. You know, we also can create with it buildings that are more thermally resistant because it can create a tight thermal envelope, more seismically resistant, and because light wood frame in a fire is basically just kindling, we also know that kind of big, thick mass timber walls are more fire resistant. So we've been looking at what material we can use. And in 2018, a new material was certified and developed in Oregon, mass plywood panels. And that was developed by some of the people who are in this room. I think Andre may still be here, Ari, I don't know if Ari's around. Lots of graduate students worked on this, on the development of this new product, mass plywood. And we as architects are very excited about this because it turns out you can use 2-inch and 3-inch panels, which use very little fiber and are very strong and stiff, and you could make nice little houses out of it, which is what we're planning to do. So we've been looking at taking advantage of prefabrication. You can do modular housing as complete volumes, but we're looking at prefabricating panels with insulation and cladding in a factory, and then bringing them out to be assembled on site, either as individual units or part of what are known as cottage clusters. And we hope that they're going to look something like this, where there's a series of panels that just fly together and create what we think are very beautiful small houses that we think we can build very economically. And the funding from the EDA will allow us to test this and prototype these out in the lab. So we've been working with the city of Milwaukee, which has been changing their zoning codes to allow single family zone sites to have multiple units. We've been looking at what's called cottage clusters, small 2-story units clustered around a courtyard. Very simple, 2-bedroom, 2-story plan, open ground floor, 2 bedrooms upstairs. We're basically just using panels to make this, and after really way too much debate, we have a kind of chase wall for plumbing, otherwise everything is just MPP panels. So this is what they look like. Those of you who are not architects, these drawings may not make sense, so we'll just move on. We don't have traditional framing plans. This took a while for us to get our heads around. We have, for framing plans, are basically just a bunch of panels, right? No framing panels. That's all it is. So we're using 3-inch panels on the outside and 2-inch panels on the inside and a whole bunch of insulation. And we've also been experimenting with other things. We'd love to use triple pane windows. They're hellaciously expensive. So we've been looking at doing some other things. We're trying to be as efficient as we possibly can about using these panels. So we're looking at the panel sizes and trying to figure out how to get to at least 95% efficiency. We're there with the 2-inch, not quite with the 3-inch yet. Again, trying to save fiber. We've been working on using something that apparently I've been calling an energy shutter, where we use a double pane window and then a translucent sliding panel to provide that 3rd layer. And using some advantages of the mass timber for routing and other things to do this. So we built a mock-up of this outside in the yard at Emerson. If you've been at Emerson, you know that the LA, this huge 3-story project, is taking up the entire floor. So we've done all our projects out in the yard in the heat and the rain. We keep complaining about this. And we've done some, using again the lab to do some CNC cutting and other things. We constructed a mock-up of this energy shutter. And then we do blower tests and, we did simulations first, but blower tests to see how it's working, if there's any leaks. The windows are much tighter fit in mass timber because of the precision than they are in lightwood frame, which is another thing that makes the thermal properties much better. And we're working on a second project, which is a retrofit project using MPP panels. This was something that we were asked to develop initially by the Department of Energy, which asked us about developing a retrofit panel using CLT and insulation for retrofitting mostly lightwood frame multi-story buildings. So we decided it made much more sense to use this brand new product that wood scientists had developed here, mass plywood, stronger, stiffer, thinner, and look at using that because we're on the West Coast, or if we were in Italy, we do the same thing, not just for thermal efficiency and upgrades, but for seismic. So we joined with Andre Barbosa, who was here, but apparently is not at the moment, as an interdisciplinary effort to make these panels. So we selected an apartment building and a typical one in Portland. This is the before and after theoretically, where that's what it looks like. And then we bring a crane in and bring in these panels and reskin the building. There's a project in the Netherlands called Energy Sprung where they do that. They scan the building with LiDAR and then produce these panels in a factory. And that's what we did. We built a one-story mock-up out in the yard, still there. We experimented with scanning techniques. We think we have it down. And then we used those scans we created to start to CNC, to create files to CNC MPP panels. And you can see it's a fairly complex panel with insulation both outside and inside. The inside insulation is really to account for the kind of variations in the facade of the existing building, and then cladding on the outside of that. And this is us. We hope to be able to use wood fiber insulation, which they're finally starting to make in the U.S., and which can be CNC'd along with the mass plywood panels. And then we had insulation and cladding. We didn't have a crane, but we used a forklift to experiment with putting these panels on the building, on the existing building, we ourselves had created. And you can see it here, and you can see this detail of the seismic strap that was created so that it works for both seismic and energy. And the EDA grant, we got a small grant from the U.S. Forest Service to do this mock-up, but we got a big grant from the EDA to actually construct a full-size 3-story version of this. So that's the end of my presentation. I was asked to talk about how we look at wood science as part of one piece of this, huge kind of mass timber supply chain that we hope will serve for both economic development and environmental stewardship here and further. Yeah.
Okay, so we have about half an hour for questions, but I would like also to spend some time just to discuss, even if you don't have questions, but you would like to share things or to, beyond the topic of the presentation. Is there a question? Oh, yeah. Is there a question in the chat? No? I saw something in the chat. Oh, I was just talking with myself. Okay, so first of all, are there questions for the speakers? Yes.
Okay, I'll ask.
Oh, wait. Let's see if this works.
Carry the other one. Carry the other one.
Oh.
Yes.
You're supposed to have microphones.
Hello. Okay, thank you to all of you for presenting. This was awesome. In the presentation, Andrea mentioned decarbonation of existing structures. Can you help me understand that term? I think I haven't heard it before.
And in fact, Andrea had like a set of 40 more slides if you're interested in this.
Yes, so we use the expression and, but otherwise it's about renovating, and refurbishing and how to renovate it with renewable materials or with wood. So we have a lot of cultural heritage protected buildings in Europe, and so how to make it now seismically safe, for example, how to make it more energy efficient by using wood. And of course, we need to talk with the preservation, and the architects need to be really careful how we can actually achieve this. And of course, then the challenges are coming in the sizes, because usually then the shelf is kept, and then how to only do it inside. So, but the decarbonization in general, how to bring the wood and wood-based products in the built environment into the existing buildings. Yeah, so I answered the other question.
That's actually the opposite of what I experienced as I started working on historical buildings where they were replacing timber with steel and reinforced concrete. Now is the time of revenge. And as Judith showed there, one of the ways to decarbonize the built environment in this refurbishing renovation projects is by adding these prefabricated facade elements, for instance, for energy and seismic retrofit. I'm not sure they do the seismic retrofit together with energy retrofit in projects, do they? Okay. So both in new buildings, of course, and in Europe there is an important build stock that needs, even if it's not cultural, the heritage needs to be renovated. What's your opinion about wood science now as a discipline? And like, if I may ask, just like picking, like Fred, when you started your career as a wood scientist, and now that you just retired, how this discipline evolves over time? And yeah, I'd like to hear your opinion.
You put me on the spot, John. Well, I mean, let me just first comment about women in this discipline. Since when I was a student at the University of Minnesota back in the 70s, we had one woman in the department. There were no women on faculty, but one female student. And we at that time had, I think, about 60 undergraduate students in the program. We had one female. I think in wood science here now today, Eric could probably tell me more accurately, about 50-50.
About 40%.
Yeah, well, okay, so that's been a tremendous change. As far as wood science is concerned, I mean, the basics are the basics. The chemistry of wood, although the techniques and our knowledge has changed, there's still chemistry aspects, there's still structural engineering aspects. There's a lot of just basic science that's the same. But as was outlined in a couple of our speakers here, that the degree programs that I've become familiar with, not only in the United States, but in other parts of the world, have broadened quite a bit. Brought it into social science aspects, and brought in the environmental aspects, although that's been around for quite a while in wood science departments. But they're becoming much more recognized these days. And I think it's an aspect of wood products that potential students can get excited about these days, just because of what we hear about on a daily basis in the news about climate change and other environmental impacts. So I think that's something that these wood science programs can build on to try to attract more students. It's the challenge, of course, it's always been this way. The challenge is getting the message out to a broad enough audience, because we're such a small, tiny discipline. Most students don't even know we exist unless they have some personal connection, and then they learn about us. So I don't know if that was helpful or not, but you put me on the spot. So.
But you will not be the only one. So now I'm going to put on the spot, and then move on, like, do you want to volunteer? I have to pick you.
What's happening? I'm being asked a specific question.
Yeah, maybe like, what brought you to Wood Science and where are you thanks to this?
I don't know how close I have to put this. Okay, I came into the wood science program in January of 2015 as an undergrad. I started just in College of Forestry because I was like, this seems about right. And just wandered in, and then I found like a couple professors who were doing research. They're like, oh, we're developing this new A&D program. And I'm like, sign me up. They're like, it's not even officially like in the registry yet. I'm like, I don't care. I'm going. So I got into there, and it really was the perfect program for me because it was the combination of the art and the science. Like I didn't want just one or the other, because otherwise I would have been bored. And now I work in, I did like in the end of my degree, I graduated in 2018, started doing CAD programs, and that really led me to what I do now, which I work for a company up in Portland, cut my timber. We prefabricate anywhere from custom residential homes to like commercial mass timber buildings. We've done a little bit of work on, we did the Adidas headquarters. We've done a little bit of work with Timber Lab and Zippo for the Port of Portland, the new airport. We've done work in Port Angeles, but basically I work anywhere from taking the architectural and structural designs and transferring those into making them actually fabrication ready. And that is really a challenge that I think needs to be developed on, because there's so much, there's so many different approaches right now. And so we're really hoping to kind of get the more information out there and standardize how people are coming into this, because everyone's coming in with completely different knowledge and coming in from very little and having to learn from the start. And I'm like, I want everyone to have this knowledge that I feel like half the people in the industry has and half doesn't. I think that would make construction a lot easier, and would also make it a lot easier to build more mass timber, because I think that's a big barrier right now.
That's wood science, your wood science knowledge.
Yes, yeah, the wood science helps, and then just the experience of being in the industry. I think there's a lot of things that engineers and architects who I work with on projects that they just, there's that lack of information that it's getting better, like over the last 4 or 5 years. I can see it's, people have a lot more background knowledge. But I think there's more opportunities out there. Oh, and there's a lot of people see me and they're like, where do we find people like you? And I'm like, I know people here. I know. They're like, where did you come from?
Questions?
Yes, yeah, this is a shy colored person who has. One of the things that I think many of us have in common that end up where we are, it's not necessarily where we headed. So I'm very curious to hear from this group of you, and we can just pass around, start with Judith. Just a simple question. Did you end up where you thought you'd end up when you started your career? And I think that's a really important question, because I think so many people think, well, if I don't do this, then I can't be that. And if I do this, then I can be that. But it's really about walking through doors and walking through opportunities. So I'd like to hear from each one of you, just briefly, just 10 seconds or something, but did you end up where you thought you were?
Didn't you start?
Yeah, you can.
Definitely not. Because somebody else mentioned confidence and self-confidence, and that's a big part of it is that self-confidence piece. And that doesn't always happen to you when you're 18 or 20 or 25. It may take you till you're 40. So definitely if I was a young person, as many of the younger people here, it's definitely not, but a lot of it is building confidence.
Thank you, Katie. I would have to say most of my career has been entirely accidental. So I did not envision when I was in architecture school that I'd wind up in timber. But you know, what happened was I was actually chairing the architecture department at Cal Poly Pomona, and I was approached by the dean of engineering to see if somebody might be interested in working with a faculty member he had who was a timber specialist on designing timber bridges in a studio. And I was like, you know, I've always wanted to design a bridge. Maybe I'll do that. So we started in these interdisciplinary studios for 5 years, and it was very interesting. At the beginning, we think the engineering students thought we were like wasting their time because we didn't have quizzes or anything. We're in this big messy studio, people are brainstorming. But within 2 weeks, they got completely into it, and it was kind of great. And then when I came here, we didn't have engineering at UO, and I remember approaching wood science and engineering. My colleague Michael Gershfield knew people here, and within a few months, Thomas Manis had this idea about this institute and asked me if I wanted to co-found it with him because we needed partners. I was like, yeah, sure, sounds good. And suddenly we are supported by the state. We have all this grant and it's really grown. And the message I have about this is that, you know, you don't know where things will go, but when things come to you, if they sound at all interesting, you should just like go for it. You know, it's like you don't know where it's going to take you. And sometimes it'll take you to cut my timbers, which we work with all the time. We work with Stefan, and was, I think, pretty amazing. And you probably didn't think you were wind up and cut my timbers when you started here. It's like, you don't know where it's going to go. So I have to say, it was, for me, it was like a very happy accident, but I think that the principle is like, that sounds interesting. I will try it and work on it. It's just a great one to follow. And I highly recommend it.
I wasn't planning to move to the US. I met Lech Mushinski in Italy, and he said, we're looking for an architect who knows something about wood, and you should apply. But actually, when I read the description, it was like, how can it be? Like, this is exactly what I want to do. And what I wanted to do was really doing research and teaching how to use wood in buildings, in the built environment. This started early, as I described in my presentation, but I wasn't thinking, you know, of the whole career, but I was thinking that simply wood was so fascinating and so special among all the building materials. So I had the luck among all, you know, these very big expert in other things to find as a master's student one of the biggest experts in timber cultural heritage in the world, who was an architect and an engineer and a wood expert. So I wanted to do my master with him, and then I did other things as a professional before moving to a place that was highly recognized as for their timber research. So I thought, okay, this is a sign of the destiny. I have to go back to my passion to it, and this brought me here. But definitely I had to somehow to recognize these signs of the destiny and to be a little bit crazy to make some decisions. But I'm happy that I took these decisions.
I think there is not so much to add because these few women kind of sum it up, that we just take our opportunities, and I was one of those. I kind of believe that if you don't say no, more of those opportunities will come to your way. I think important part was to be curious, always open-minded, and kind of like a little bit skewed one way or another. I would say one was my mother, who was not able to have her education, and she was a very smart woman, and she was kind of deprived and denied to go to school. So I had to her every day of my young life, education is everything. You have to complete your education. So without kind of knowing it, I was just kind of going higher and higher and took my opportunities. And I didn't plan to end up in US as well. So here I am.
Well, you heard from my presentation that confidence was not there initially. And as you know, a young person, you just don't know for sure. Well, most people don't. But being open to opportunities, being in the right place at the right time, and recognizing that, oh, that could really work, and then not being afraid to try. I think a couple things: you need to rely on your colleagues to learn from them. That's important. And also, if you find a mentor that you really click with, use that mentor and learn from that person, because that person, the mentors, I think, are very important. Even if it's a female mentor for females or male, it doesn't matter who they are, just that they're somebody that you can look up to. And I think that can really help people. I had a lot of those mentors.
Well, I sort of did, because since I was a kid, I knew I wanted to be a professor. And then when I went to undergrad, I wanted to be a professor, but I thought I was gonna be in Brazil, not in Mississippi. Yeah, but the opportunity, and I actually met the professor in Vegas, like, who does that, right? So that's why it's so important to go to conferences. Vicky just talked about mentors at SWST. I first started as a student, and I have so many mentors there, and it's a great opportunity. And ask questions, nowadays we have this hard time to ask for help. We usually have to pretend that we are strong and we know it all, but we don't. So ask for questions and ask for help. So I kind of did, but I didn't, it was not my plan to be in Mississippi, so.
And for me, it was when deciding where to go, what to study. I had the application for math already prepared, but my twin sister submitted there, and I said, well, maybe I should try something else. And so I wrote a new application, because this was the only thing I kind of was interested in, or was kind of I knew. And then when I started studying, I actually was learning about all these materials that I was playing with in the workshop at home, that got me inspired. And then, of course, I never thought that I will go for the professorship, but then I just go and I continue learning, and happy that this is how it went. But I think that it's so important that you find yourself in the field, because the passion it's kind of not just the job, but it's actually a way of living, being a researcher, and trying to pass this passion further to others.
That was a good question. Eric, do you have any questions? No,
I can put him on the spot.
So I have to put somebody else on the spot. Okay. Can you share something about? Say, I want you, I'm coming. Your experience at GLO now.
Oh, yeah, it's very eclectic actually. So I wanted to go to a liberal arts college and study literature. But if you have a Peruvian mom that decided at your birth that you were going to be an engineer, I applied to be in a natural resources engineering school in Peru, La Molina University, and I was in the methodology department. And then I met a group of crazy people who were going to the Amazon to do forest inventories, and I applied to one class, and that was it. I changed immediately from the science college to the forestry science engineering college. I was devoted for almost 15 years to forest conservation. So I was like doing hardcore rapid assessment programs to do forest inventory. I was doing a lot of wildlife studies. I was a field scientist, and I was project director at one of the most important conservation NGOs there. And then Jeff Morrell met my sister at a conference in Chile. And Jeff and Sari Robinson offered her a PhD scholarship here. So everyone in the family was celebrating, including me. I came here to help my little sister set up in the United States. And I was offered the same thing, a scholarship, because they asked me, what would you do with spalted wood? And I was like, oh, it's very easy. I can develop a system to pigment wood, so we can go to Home Depot and buy flooring in any color we want. And they offered me a scholarship, and I told my mom, no, it's okay. I have my job, I'm 37 years old, I'm fine. And my mom told me, well, then I'm not going to talk to you anymore. When an opportunity knocks at your door like that, you open the door and you say yes. And I quit my job of many years. I left everything and doing food and pisco sour. And then I came here, and from being a forest, because also the bottom is that when you work in forest conservation, your heart gets broken many times because you're not always successful. And I discovered that people value more a forest when the forest is actually used and you find ways to give it value. And for sure, spouting, it's one way, but there's so many others, and there's so much lack of knowledge. We are in this world, we understand it, but I would say like everyone who's making big decisions on construction and forest management that are not us, they have zero understanding of how amazing this material is and how many possibilities it has. So I became a wood scientist, and I am in love with the material, all the things, all the doors that it can open. And with the time, besides spalting that was mainly biodegradation, I fell in love with wood anatomy. And that's what I have been doing for many years now. Now I'm managing director of the Wood-Based Composite Center, which is great. It's a research co-op, and they develop amazing projects. I meet amazing people, but at the same time, I still can steal some time on my weekends and work on my papers or do trips to the Forest Products Lab and be working with wood anatomy, because there's so much to learn. And it's true, the more you learn, I think when you get a PhD, you realize that you know nothing. You need way more time to learn more. That's it. Oh my God.
Okay. You want to learn more from our alumni? Yeah. Christina.
Right. Well, thank you. I actually am one of those people in this room that don't work with wood every day. However, I do appreciate the connections and the people and the experience I've had here. So I did a dual master's program with structural engineering and wood science. Before that, I actually didn't have any knowledge of wood, but I learned that we had a really awesome wood science program in here at OSU, and I was really like, I shouldn't miss this opportunity. I should figure out what are they doing, because when I was doing my undergraduate, all the classes talked only about steel and reinforced concrete and other types of concrete, and not so much about wood. So I did that. After graduating, I started working and still work on the water and wastewater treatment design, which unfortunately doesn't utilize a lot of wood. Wood doesn't do so well with water treatments. However, recently, our company, as the rest of the region here in the US especially, has been seeing a lot more requests for using wood. And even in our office, there have been a few emails coming and asking for a structural engineer who has experience with wood design. I think there was some other mentioning that we can achieve more with wood, but we don't have all the preset tools and standards as an industry. And I think we also are a little bit slow, you know, to change and adapt all these wonderful products and literature that has been published. So I think for me, I'm here today more to just learn about what has been happening in the industry, and just be open about connecting and finding resources, because again, I think there is a lot of potential, and I really think OSU especially, and all the collaborations that have been happening through here can be useful to the industry. So thank you for what you do, and keep it up, and hopefully we, including me and others, will catch up with the research and the innovation that has been happening here.
Thank you. So besides this audience in this room, we have some people who have joined from different parts of the world online, and we have a very important question. And Eric is going to read the question and answer the question. He's our department head. He has an answer to this question.
Been an ongoing battle between Maria Pal and I requested to be in the background during this event, and this is not how it's supposed to work. So the question that we have, and I'm going to be able to totally pass the buck as soon as I read the question. So, how can a woman in a country such as Nigeria cope with discrimination and frustration by men in wood science, and are there opportunities available for women to get scholarships for study in the US? So I answered the last part, and definitely there are lots of opportunities. We have lots of inquiries right now from Nigeria, so there's multiple people in our system already. And in the room, we have somebody that might know something about this country if he was willing to talk. Because I don't have a good answer for that question at all.
Well, it was important. It was important to share that there are scholarship opportunities, and that we are considering a lot of students from many countries, and many countries in Africa, and from developing countries that of course are those the student population that struggle more to find funds to come and join us. So do not give up, because there may be opportunities. Would you like to share something about how you ended up being here? And even if we have a male student, but this is a round table. Come on, it's not.
You very keen and have to do that. So I'd say that typically it's the same population, and it's the same issue that we see everywhere around the globe that we also have in Nigeria. The forestry and engineering sector is male dominated. So I understand why any person like a woman will feel a little bit intimidated by men. But again, the thing is to keep pushing, keep trying for these opportunities, be open and reach out to people, male or female. I know that
a lot of people have come to me on LinkedIn saying, oh, I want to get into your program. How did you do it? We are always ready to share. There are 3 Nigerians here right now. So if you look up our profiles on LinkedIn, you can send us messages. We would not say, oh, because this person is a woman, we're not going to respond to it. So just be open, ask questions. I keep telling people that when I came, there was no Nigerian here. I didn't know anyone, I just applied. And then after that, I think I know that like 7 Nigerians have tried. Some have gotten in without funding. I think I know that 2 more people are trying to come that are Nigerians. So just keep applying. There are many schools. There are lots of scholars, Nigerians in forestry. There is Samuel in Mississippi, Ahmed, Messi. Yeah, we're everywhere. Just be open and ask your questions, and don't be scared. Nobody's going to intimidate you. You're coming to the US. You're leaving the shores of Nigeria, and if you are not bold, it's going to be difficult. When I left Nigeria, that was the first time ever I was leaving the country, and I knew no one. Well, I'm going to go, and it took me like maybe 3 weeks to see the first Black person in Corvallis when I came here. It was intimidating, but it's fine. You just keep pushing. Now I'm very, very comfortable. I'm happy where I am. It's a great department. People are offering lots of help. So yeah, there is help everywhere. Just keep attending.
I really enjoyed this conversation. I think we are good to move to the reception unless there are final comments, questions. I want to thank you, everybody, for attending, for participating and sharing. Thanks, Eric Hansen, for envisioning this celebration. And to all the women ambassadors who are here today. Thank you.